Hello, I'm Frederik Krebs from infinityPV. We made a series of videos for you showing exactly how perovskite solar cells and modules can be manufactured using roll-to-roll processing. In this video, we will start with how your carrier substrate is selected and prepared for coating. We will go through many of the cases that you may come across when starting printing of your solar stack, either onto bare plastic foil, onto a barrier material, or perhaps a plastic foil with an electrode structure pre-patterned on it. Roll-to-roll processing of the flexible perovskite solar cells starts with a carrier substrate, which is most typically comprised of polyethylene terephthalate or PET. It's a plastic material that has excellent optical and thermal properties, so it can be heated and cooled down many times without stretching or contracting too much. For many printed solar cells, it starts with printing the first electrode, but for the perovskite solar cell, the carrier substrate typically already has a layer of semi-transparent conducting oxide on it. Typical electrode material would be indium tin oxide, or ITO for short. So whether you're starting from the pure PET or the PET with an ITO layer on it, you will need to prepare it for the following steps, which we detail in the following videos of this series. The special layers that you are about to apply, they will require that the substrate is very clean and possibly also patterned such that the junctions that you will end up with in the end are correctly interconnected. Especially important for modules, but can also be so for junctions if you have a special geometry. Cleaning can be carried out in a number of ways. By the simplest way, contact cleaning, where you have a system with a rubber roller that has a tendency to pick up dust. You roll this over your substrate and you pick up the dust from this roller using a sticky roller with a sacrificial adhesive. This can be removed later as the dirt particles build up. In the case of the pure PET, there's also a large tendency for static charges to build up. And these can really affect your coating and printing. And here, an anti-static bar is a very useful tool. It essentially removes the charges or equilibrates the charges on the surface. But in the case of conducting ITO, this is normally not needed. So going again back to the case of pure PET, that has a low surface energy, it can be useful to treat the surface with corona or plasma, which is a process that generates reactive gas molecules that undergo chemical reactions with the surface, in addition to also burning off impurities. And this effectively increases the surface energy of your surface, making wetting much better. It will enable you to make very well-defined coating and printing, and typically also result in a much stronger adhesion. With conducting surfaces such as ITO, again, this is normally not necessary or even recommended, as many of these reactive treatments can destroy the ITO properties. Other options for cleaning are very simply washing the substrate, either with a chemical, with a solvent or soaped water, and you get a very clean surface. It's also possible to acquire foil that have what is known as a pristine clean surface, where the surface has been covered with the liner during manufacture in vacuum, so as to keep it completely clean during all handling post-manufacture. This liner is stripped from the surface just prior to coating, thus ensuring complete control over your surface until you need it exposed to your process. Another aspect of preparing your substrate in the case of ITO is that you need to pattern it into an electrode structure. This is typically done by laser scribing, where you selectively remove the conducting ITO in a specific pattern, matching your desired electrode structure. And this is best carried out with a laser wavelength where ITO absorbs and where the PET substrate does not absorb so much. That way it's possible to convert your fully covering ITO surface into electrically isolated lines or islands of ITO. And this can also be achieved in another way. If you don't have a laser, you can very simply just print or coat an etch resist, a positive resist, onto the ITO, followed by etching away the parts that you didn't want. You strip the resist away, wash it and dry it, and you achieve the same thing. So now we have detailed how you select your substrate, how you prepare your foil for starting the printing of your solar stack. And in the next video, we will show how to prepare the first layer, which is typically a charge selective layer, and we'll show several examples of this. So please stay tuned.